Hey ladies and gentlemen, welcome to the video lessons for Chapter 0, Section 3. Chapter 0, Section 3 in your McGraw-Hill Algebra 2 textbook. This section is covering a review of how to factor a polynomial. This lesson's videos will consist of 4 videos covering our 4 different types of factoring. So in Algebra 1, excuse me. In Algebra 1, we have lots of different types of factoring, and 4 of them are what we're going to be reviewing, and those are how we actually factor a polynomial. So there are 4 different methods we're going to cover. Factoring out the greatest common factor, which is key because we should always be doing that first, checking for a greatest common factor. And then 3 of our different types of factoring, which are difference of 2 perfect squares. Remember that will only work with binomials. No other type will work. Trinomials, where the lead coefficient is equal to 1. When I say lead coefficient, I'm talking about the a value in ax squared plus bx plus c. And then finally, trinomials where the lead coefficient is not 1. In other words, a does not equal 1. And that actually turns into factoring by grouping, the way that I teach it and the way that I expect you to do it. So this first video will cover that first type of factoring, and that is the greatest common factor. The greatest common factor is when we have 2 or more polynomials. They have a greatest common factor, 2 or more terms. Polynomials, terms. Terms is probably a better way to say it. Let's put terms in that blank. If we have 2 or more terms, oops, too far. 2 or more terms, they have a GCF if their coefficients have a common factor or the 2 terms share a common variable. So this is a review. So it's going to be, I'm working under the assumption that you remember how to do this. If you don't, you probably need to set up a time to come work with me specifically on how to figure out the GCF for the various terms. So what we do is we go in and we ask ourselves a question. 12 and 30. What is the greatest common factor of 12 and 30? So what we should think to ourselves is 12 and 30 are both divisible by 3. And both terms have at least an x squared and at least a y. So our GCF is 3x squared y. So we're going to write that in front of a set of parentheses. Now what happens is we take that 3x squared y and we divide both terms of our original polynomial by 3x squared y. So we're going to do (12x to the 5th y squared divided by 3x squared y) and 30x squared yz cubed divided by 3x squared y, and that will give us our factored form. So 3x squared y is on the outside, that's our GCF. 12 divided by 3 is 4. Then we apply the quotient rule to these variables. So x to the 5th over x squared is x to the 5 minus 2, or x cubed. Y squared over y is y to the 2 minus 1, or y. 30 divided by 3 is 10. X squared cancels, y cancels, and I still have a z cubed on top. So my factored form would be 3x squared y times the quantity 4x cubed y plus 10z cubed. Essentially, when we factor something, we are undoing multiplication. We're pulling it apart. And the GCF is like we are undistributing. We're pulling out the greatest common factor. If we were to then distribute, our answer should be the original polynomial. So let's do letter B. We'll do it in a different color so we can't confuse the work. So again, we have to ask ourselves, 28 and 7, what is the common factor there? Well, 28 and 7 are both divisible by 7. And then we also say to ourselves that both have at least x cubed and y squared. So our greatest common factor is 7x cubed y squared. And again, what we're going to do here is we're going to divide the original problem by 7x cubed y squared. So on the outside we have our GCF, 7x cubed y squared. On the inside we carry out that division. 28 divided by 7 is 4. X to the 5th divided by x to the 3rd is x to the 2nd. And y squared divided by y squared is 1. So it just drops out. 7 divided by 7 is 1, so we don't need to write that. X cubed over x cubed is 1. Y cubed over y squared is y. So you should have a y or a 1y. So there's our first two examples of factoring out the GCF. We're going to do two more on the next page, so if you think you know what you're doing, you should pause the video and then try them and then watch the rest of the video to see if you did them correctly. So the next example here, 15x to the 6th y squared minus 10x cubed y squared, or y cubed. 15 and 10 are both divisible by. Let's change the color on that if we can. Yeah, perfect. Okay, so we have 15 and 10, they're both divisible by 5. And again, the goal there is to find the biggest number that both numbers are divisible by. They also both have an x to the 3rd and a y squared. So we're going to be factoring out a 5x cubed y squared, which means we're going to take the original problem and divide by 5x cubed y squared. So that would be 5x cubed y squared on the outside, 3x cubed minus 2y on the inside. Now this doesn't have to be limited to 2 terms. We can expand that out to cover 3 terms. All we need to change in our thought process is all 3 numbers are divisible by what? So we would think to ourselves, all 3 numbers, and really I should change my color, so let me switch to red here. Too far. All 3 numbers are divisible by what? Well, the biggest number that divides them all evenly is 2. In addition, all 3 terms have an a b squared, and a c cubed, because I'm working under the assumption that this is supposed to be c to the 5th here. I'm not really sure what happened to the original problem, but that should be c to the 5th. So we're going to be factoring out 2ab squared c cubed, which means we're going to divide the original problem. Each term gets divided by 2ab squared c cubed. And eventually you might get good enough at this that you don't need to write this step out every time. But until you prove that to me, I would expect to see this step every time. So that's what we're going to do. We're going to divide each term by that, which will give us 2ab squared c times 9abc squared plus 3b squared minus 7a to the 4th c. And that is how we factor out the GCF. That completes the first of 4 videos for Chapter 0, Section 3 of your Algebra 2 textbook.